let's first work. We're going to talk about each of these. Let's first work on number one. We talked about last time, but now we're kind of looking at it in a slightly different way. So number one is double existentials, is what I'll call it. And that goes like this. The general form is there exists an x and dx such that there exists a y and dy such that p of xy. That is the general form. So, using our example here, let's make an example. So, for example, we could say that there exists a U and DU, the all-star players, such that there exists a V and DV, Lakers, Nuggets, Celtics, Heat, such that our UV is true. U plays on team V. So the way you write that in English is you'd say, there is an all-star player playing on one of these teams. That's what this statement means. This statement's saying that there exists a player in the all-star players instead of all-star players, such that there exists a team in these teams where that player plays on that team. So what that means is there's an all-star player playing on one of these teams. Make sense?
Could they be playing on multiple teams?
No, well, like in real life, you can only play on one team, right?
Well, yeah, but like with the context
right?
of
Like,
basketball removed.
What? Yeah, but with basketball removed, this isn't saying that there's not more than one all-star player playing on more than one of these teams, right? It's just saying that there's at least one all-star player playing on at least one of these teams.
Okay, cool.
Right? Okay. So, and here's the thing to note. Let's talk about this is going to be our claim. This is our claim right here. This is true. But how would we prove it? And here's the thing to notice. Let's go ahead and let this right here equal what I'm going to call P with a little squiggly on top, X. Notice P with a little squiggly on top, X, meaning there exists a Y and dy, which is a P of XY. This is a predicate, right? If you plug any specific X in here, if you plug any specific X in here from X's domain, dx, this will be a statement. It's an existential statement, but it's a statement. So this is just a predicate. You plug any X in, this becomes a statement. So this right here, there exists an X and dx such, it's really cool, there's just X and dx such that little squiggly, I'm not saying not px here, that's just like the thing of a p just to kind of make it seem different. Yeah, This is just an existential statement. This is just an existential statement where the predicate happens to be another existential statement, kind of. So, how do you prove an existential statement?
Find a true example.
Exactly. Or actually, not even a counterexample. It's just an example, right? To disprove it for all, you find a counterexample, because if I find an example counter to what the claim is saying, but to prove there exists, we're just saying there exists one. Let's just find the one that exists. So proof. Yes. Proof. Let U equal LeBron James. You might have heard of him, Safa. And then,
Nah, who's the?
and then the second best basketball player of all time. Second.
Yo! First!
So then let U equal LeBron James. We want to show that. So now, this I'm going to call squiggly with a U. Right, it's a predicate, wants to play anything there. Want to show that R of LeBron James is true, right? Because this statement is just equivalent to there exists a U and du such that R, well, squiggly of U. Just an existential statement. Prove an existential statement, we get to define one that satisfies the predicate. So we think LeBron James satisfies the predicate, so we just want to show that LeBron James does in fact satisfy the predicate. But R LeBron James, notice R, I'm just going to call him LJ, is itself an existential statement. So we're kind of nesting these existential statements. That is itself this statement right here. There's just a V and dV says that R UV. So we need to show this is true. How do you prove an existential statement true? Find an example. So now we need to find example of V such that example of V in dV such that R of LJV is true. Because once we do that, we've proven this existential statement true. This existential statement is R squiggly U, which is the predicate of the whole thing. And so then we've shown that there exists a U and du that makes this predicate true, so then the whole thing's true. Just wait till we get to triple quantifiers. Actually, we're not even gonna do that because it's all the same. But anyway, so we have this. So then what's a V, Safa? What should V be?
The Lakers.
Exactly. Let V equal the Lakers. LeBron, for all these non-basketball fans, LeBron James plays for the Lakers. I'm going to let V equal the Lakers. Then, notes, LeBron plays for the Lakers. So, R of UV, where U is LeBron and V is the Lakers, is true. Thus, there is a player. Oh, here we should note LeBron James is an all-star. That's important, right? Because our U had to come from DU. And remember, DU is all-star players. So, thus there's a player in DU that plays on a team in DV done. So I hope you see here that we didn't really do anything new. All we did here, exactly. Whoops, is Benet. Basically, just prove them one by one and use that chain to finally prove the statement as a whole. Exactly, right? So we need to prove this. So we need to prove this statement, which is an existential statement with this predicate. So we need to find something in this domain. We can plug in this predicate and make it true. So we found LeBron James. We know we had to prove that makes the predicate true. And to prove this makes the predicate true, we have to prove this statement true. And so even if there was 1,000 there exist statements, we could do this. I mean, it would take a while, but it would be just as easy conceptually. You have to prove that next there exists statement, the next one, the next one, the next one, until we get to this. Any questions? Oh, right. Let's talk about disproving real quick. So let's say we say instead, there exists an A in 1, 2, 3, such that there exists a B in 4, 5. With A times B equals 0. So this right here, that's what we call the predicate QAB. So I'm going to call this to be Q squiggly A. Whenever you plug A in, this is an existential statement. Is this true or false?
False.
False. Right? Because no matter what we put from here, and no matter what we pick from here, you multiply them together, you're not going to get 0. So there does not exist an A in 1, 2, 3, such that there's the B in 4, 5 with A times B equals 0. So how do we disprove that? How do you disprove existential? Because remember, this is just an existential. This is equivalent to there exists an A in 1, 2, 3, such that R squiggly A. So is that you just
exhaustion?
Method of exhaustion. Exactly, right? You have to show that for all A in here, R squiggly A is not going to cut it. R squiggly A is going to be false. So, to disprove, all I have to say is let A in 1, 2, 3, then A equals 1, A equals 2, or A equals 3. If A equals 1, then, okay, in the case where A equals 1, we're trying to show that this is going to be false. We're trying to show that this little predicate here is false for any A you plug in. That's what makes this existential statement to be false. So we want our R of 1 to be false. How do we do that? Well, this is an existential statement. Now you have to prove that this statement's not true. So how do you prove an existential statement false? You have to show for everything in there, for everything in the domain, it makes the predicate not true. So, all right. B can equal 4 or 5. If B equals 4, A times B equals 4 times 5, which equals 20, which is not 0. If B equals 5, not 4 times 5, I'm sorry, 1 times 4. If B equals 5, A times B equals 1 times 5, which equals 5, which is not 0. And then you do the same thing for if A equals 2, And the same thing for if A equals 3. And then thus, and on like a test or something, you'd actually write this out, but I'm just trying to save time here. Thus, by method of exhaustion, right? There does not exist an A in 1, 2, 3 such that there exists a B in 4, 5 such that A times B equals 0. How do we know? Because we checked them all. So again, exact same thing. All we did here is really just disprove an existential statement where the predicate happened to be another existential statement. That's fine.
I have a question.
Yeah.
So I guess it's just like the observation that like method of exhaustion is not particularly efficient. And
No.
in this case, you could say something like, well, you can see that it's necessary if A times B equals 0, it's necessary that either A or B or both are 0. And you can see that 0 doesn't exist in either domain, and you can
Yep,
make a
and that's
proof that way, right?
you're totally right, Alex, and that's coming
But
up.
how would we? Oh, okay.
That's coming up in section 4.1.
I see.
Oh, glare apart for yeah. Sorry about that. All I'm saying here is that do the same thing for 2, same thing for 3. You're gonna get similar results. Okay, so real quick, before I leave you, the punchline, which is going to be the same thing we said last time, but last time I was rushed. I hope this makes more sense now.